wanted to see what these four contestants came up with. And I think, out of fairness, we should really start with Peter Hall, because he was the very first person to talk about what he does. And Peter is out of England, but James, you know all of the details about him. And you can talk about the conversation that you had with him when he first, called you, and then you told me what might happen.
All right, so here's Peter Hall.
So here I am back with the Omnicopter flying outside this time. So this is a vehicle that can fly in any direction and at any orientation. If you saw my last video, it's a bit of a closer up shot of it flying about indoors. So here it is with a bit more room. You can see it can move quite fast because it does have enough thrust to hover in any orientation. I've now fitted a little switch so it can in fact rotate on the spot while hovering. This is just in stabilized mode, so I'm controlling the throttle and the forwards, backwards, left, right thrust manually.
He's explaining as if you're just a typical drone pilot,
a weird way if you're
explaining that it can rotate, that it can translate in any direction. He's just going over the basics of the nature of the craft.
Because it's so symmetrical, it's quite hard to fly a line of sight like this. So I turned up the roll rate a little bit there, and you can see going faster it's a little bit.
Here, so we got the center roll. Right, you got that done.
It just every time it has to reverse one of those propellers, it has a little jump as it takes the time to stop and go the other way. So that's now in loiter mode, so that's the autopilot is controlling.
I did notice in his there's a bit of jogging when he goes over top center.
Gets pretty well
it's the 3D propellers.
In fact, it does
because those motors have to start and stop in the other direction.
Keep it in the one spot whilst rotating like that.
There's a little bit of jerkiness.
Try and bring it in a little bit closer.
Yeah, because he's got 6 on his, right, with the.
Yes.
So I've got this rotation just so with
3 of the 4
switch.
completed
just flip my switch off and it rights itself. And of course you can fly around just as fast as you could when it wasn't rotating, whilst rotating. So
and that to me is a fantastic display of the capabilities of the Lynchpin. Being able to rotate
next time and
in any direction and move in any direction.
This was really
knocked that out of
just
the park,
trying out the autonomous functionality. So it will loiter, which means auto missions. RTL,
yeah, Chris
will work.
When Chris first saw this, it was literally the expression of everything that we had been talking about. We were super excited, for his submission, but I don't even think that he submitted it. Didn't he just put it out on YouTube?
No, he did. Yeah, no, that was the way he transferred the video was over YouTube.
Great. But yeah, when he did you tell the story of, how he called and what he wanted to do? This was like literally a week after we had started the competition. How far in the competition?
It was like, hold on, let me kill his audio. We saw this like 2 weeks after the kickoff of the competition. Like I emailed, we had the introductory videos was the first requirement, and we only had a handful of people complete those. 4. And he was not maybe 2 weeks at the most out from that initial date with this. And this is like his test footage inside of his house before he took it outside to complete the video we just saw.
A couple of comments on that one.
Yes.
Yeah.
Just kind of from a point of view of just flight testing and things like that, some things that I would like to see on capabilities at least. And that one was showing some of these things, but there was a lot of linear translation, but I'd like to see some circular paths, flying circles around things, for example, as well as, just the linears. it was a while, but he finally showed it, some of the XYZ rotation while he was on a vector. So they finally did that. And then he showed some rotation in all three axes while just still in a hover. So I thought that was a good capability demo. Like to see something that we call agility, which is the ability to kind of change an energy state. In this case, it'd be like to go from a complete stop, accelerate as quickly as possible to top speed, and then stop and see how quick it could take them to stop. So that's a demonstration of agility that can be translated into lots of different things. He was also showing a lot of linear motion, a little parallel to the ground. Like to see some more action in the vertical, and in even some 45-degree planes, from the ground. And finally, I don't know if anybody's done this much yet, but I did get to see a little bit of it when he was in that room inside the house. I'm interested in how these things can maneuver in a really tight space. So they'd be doing some slow, careful, specific maneuvering in some real tight spaces. But his capability of this one was really, really good.
Yeah. Well, I think the same thing. That's why his entry video literally inspired so many other people to begin to comment, because when we first started the competition, the attack from the community was visceral. It was, they felt as if I was asking them to jump to the moon. They thought it was impossible, to make this thing fly. They thought that there would be so much conversation between the engines and between the vortices that's created, that it would just throw it off, or the weight of the tips of the wings spinning around, how it would throw off everything. No one really wanted to have any faith in it. But once they saw Peter Hall's thing on YouTube, the list of comments was phenomenal. They were like, "This is the future." Here comes, here comes alien. This is alien technology. So I was really thankful. But one of the things that you just talked about, being able to maneuver in a tight and small place, I think Chris Moulter, his really demonstrated that. This was our second entry, second person to complete this. And James, maybe you can talk about, who the good doctor is.
Yeah, Christian is he's an aerospace engineer. He's got his PhD in aerospace engineering, probably a couple of other things. But his talent and his sense of humor really, I adore him as a human, and his spirit and creativity definitely come through in his entry video. It'll be a shame if we can't hear the sound, because his voiceover is fantastic. He does a great job of using a bit of humor in his narration of the entire process, from discovering the competition through creating the elements that he used. I mean, he has a CNC machine in his bedroom, and he has footage of him just actually milling the parts and trying again. It's a very interesting process to watch him go through, but also a lot of fun.
We didn't get Vance's perspective on the on Peter Hall's entry. And mind you, we'll be able to edit this and really tighten it up for what we want to say. But what was your thoughts on Peter, from your perspective, from the moment that you had learned about from the potential of the Lynchpin, and in an association with people you've talked to about its potential and what you saw in Peter?
I thought Peter's demonstration, the whole presentation of it, was the way he manufactured it, the way he put it all together. I'd like to find out a little bit more about that, the composites he used, the batteries, and stuff of that nature. How much does it weigh? What's the payload of it if it was to carry something? I'd also like to know what I'd like to see it go in that vertical plane from stop to start, and see what that PID loop would be. Would it stop immediately? What's the ceiling height on them? Do the blades need to be feathered or changed? I'd like to see almost not a somewhat of an obstacle course, to see how agile these things are and how controllable the center linchpin can be under really good controlled circumstances. Weight and balance, the stopping and starting, the round, like Brett was saying, going round in circles and turning at the same time, going around in circles, maybe triangular, coming under something, up, overstepping steps, stuff like that. Because the linchpin, the center of the whole concept is agility, if they're going to use it in this format of a flying apparatus of some sort. So it's there. I think the interface, because in my mind, I see a whole bunch of these together with software written that you can, write the software and have it stop and change and then do certain applications and then come all back together again through a software platform. It's doable. I mean, we do it all the time. So, but the presentation I thought was great. It looked good. I just, like I said, I would like to see a little bit more, almost like an obstacle course type thing there, and just see how agile and how good these things can actually work.
One, magnificent. And Chris, you've already spoken on it.
Yeah, I think he did a good job on the build, and the flight demo was a good job on that as well. He caught the rotation over his top center, and like I said, it did jog some. So, and he did use the bi-directional props, and he used 6 as opposed to 12 as per the original specs of the contest, right? So,
yeah.
And his design was pretty close to the original linchpin specifications, although he did add some reinforcing cabling and stuff to, I assume, to take out any vibrations and such. But he stuck pretty close to the original file that was sent him. So good job.
Yeah, I saw that with the cabling.
Yeah,
it looked good though.
Everyone's sort of, the one thing you'll see is that everyone solved different problems like that differently. Peter used the cable, and the other 2 gentlemen, or the other 3 gentlemen, solved that same problem slightly differently. Some with structural changes on the inside of the geometry, and you'll see how young Kevin solved it. So it's interesting. And the one thing I do want to note as we go through the rest of these clips is a lot of everyone faced either environmental or, how do you say, political
COVID.
or legal. Yeah, COVID. There was this took
Sure.
place under, especially for our European friends, under fairly strict off and on rolling lockdowns. So that in addition to the fact that it's an incredibly difficult thing to fly line of sight.
Oh yeah.
So they had just enough time really to program it, like overcome the software hurdles and then the physical hurdles of the construction of a viable frame, and then the demonstration, all in a what I would consider to be just a razor thin, timeline. So,
yeah.
That's the only thing I want to just kind of keep in everyone's mind as we see the rest of the demonstrations, is that to do any of this, I believe, in the timeline they were given is nothing short of miraculous. And I do have a fair bit of faith that given another, few weeks or a month or so, to gain proficiency in operation, I believe that they would have been able to pull off all of the maneuvers. I think that if you look at the ingredients, like the little maneuvers here and there, you can see that they all do add up to a lot of what we're talking about, though it might have been, more of a nervousness or just a fear of destroying the thing they were building that may have kept them a little more on the reserved side.
I mean, definitely operator interface. It's going to be different from each one. I'm interested in the construction of it a little bit.
Said something I thought was pretty insightful there. There were 2 things that kind of came to mind. One was that these guys had a real tight timeline and they all met it. So, that speaks to the fact that these guys are all fairly proficient in what they're doing. So we may be able to take that a little bit off of the table as far as a competitive advantage one way or another, since they all met the timeline. So that's good to hear. And I guess, the other one might be that they were able to make it do almost everything that they were told to do. Some people went a little above and beyond. Like I never got to see the one with the 12 rotors, but I think we're going to see that one today, right?
Mm-hmm. Yeah, that's
that's
right after.
Wow, that's kind of if you think back when there was the YF-23 and the YF-22, they were doing the fly-off competition. The YF-22 won that because they went the extra mile and launched a missile, supersonic, and that wasn't part of the requirement. They just kind of went above and beyond compared to the other team, and they were picked for that. So that's another thing that I'll look toward. The ability to solve certain problems using different methods. I guess we'll see that a little bit in a few minutes, and James will probably point that out to us. So I'm looking forward to that.
Mm-hmm. And one of the things we should note about Peter, part of the competition was to turn in the programming of the software for the flight controller, to the competition. And, but he released his open source, even after we spoke to him about that. But he did something else that was really beneficial to the rest of the competition, and it was almost a democratic way of approaching competitions. He did put 4 videos together on how to build a linchpin, showing everything that he did in the middle of the competition. And what was great is I remember a couple of the competitors, before they had saw his videos, they were like, does it have to turn over completely, or can it go side? And they saw his videos, and then they went and utilized some of his stuff. Like he used a GPS, and as a result, they utilized the GPS and, really improved competition. So, he's a bold cat, and truly one of the smartest ones, because he jumped out and did it before anybody else was able to do it. And I got to give him credit for doing something like that, But why don't you introduce Chris Moulter?
Yes, this is the good doctor from Germany.
Yeah, but if we don't even hear his sound, then we can edit and put his thing here. What we could do is, they've all seen it before and may be able to comment off of it, or maybe they can watch it on some other some other system that they have, just for a minute to
Okay, I'll scroll through the video, and if you want me to pause or stop and then make comments, anybody here, then let me know, and I'll hit the pause button.
We would need to be able to hear it from staff.
How do I share? Let's see.
We can see it.
Let's do Skype. Audio, video.
Because the good side is when we air this will literally be the actual video playing.
Right. I'll at the very least I'll match up the sound.
Mm-hmm. But
it's not going to let me do that. No, I don't think.
No, don't worry.
Well,
but
okay, I'll hit play on the video, and you'll have some footage while we talk about it.
Mm-hmm. Now, one of the things that I like the most about Chris is, was the humility at which he approached the competition. Whereas Peter didn't even mention that it was a linchpin, part of the competition from the moment he went outside. This good doctor, immediately was like, linchpin competition, let me see what this is like. And he went about describing how the linchpin, fits as the common factor, or as the relative balance position in the universe, and everything, it's the same from every particular angle. And he said, well, let me build a couple other things to help give it some support. But he went into it and thoroughly explained every aspect of it, and the landing on the counter, when he rode in there and landed it on the individual counter, that made a big impact to how I saw things. And this is what Vince was talking about, the actual construction of it and putting the hands together. And he'll actually describe what he did with the programming of it and having to add stuff. But he handled all of those little bitty things. But then the biggest thing, he added the camera to it.
Due to a detailed physical model, the Lynchpin I've built flies also well in GPS-denied environments.
But here, you're going inside, nobody's panicked. Now, I've never flown a drone before, so I don't know how difficult it is to make a drone fly in all orientations. If I'd ever flown a drone before, I would have probably said you can't fly a drone in all orientations and you can't possibly land it and do the things that you can do with this. So that becomes a great benefit a little bit. But I love this.
One of the things we think about a lot in flight test is that we're trying to separate the pilot from the machine itself. We've got to be able to figure out, what are the capabilities of the machine versus the capabilities of the man with the machine, because that just speaks strictly to proficiency of the pilot. So those are kind of tough things that we'll need to pay attention to.
Now, what I was sad about was that he needed, two people to control it. And I don't know if one was for the camera or one was for, or what was for the actual machine, and maybe you guys can explain that to me.
Yeah, I believe you're right, Terrence. That is the case. I think the second pilot was basically controlling the camera, while the other was doing the pilot.
Right. I mean, I personally think that, I definitely see what you're saying as that being sort of a weakness, but I think that it's actually beneficial. Given maybe not for the purposes of the contest, for the competition right now, that might be a hindrance, but I think for the future implementation of a linchpin in practical use, I think having the ability to split those controls between two people while one person can handle one task like the general movement and the other person can handle the observation that the linchpin is conducting is I think that it to me it speaks to a lot of possibilities as far as just immediate practical applications of the linchpin. At least a single linchpin in the air performing a task.
And from a military standpoint too, if you want to think about that, there's nothing at all wrong with having an operator and then also having a sensor operator. So you've got, just like you said, a pilot, and then you've got whoever's operating whatever sensor load it happens to be, particularly as you might scale this thing up.
Right.
Yeah, exactly, Brett. I agree with you there too. And it's coming from the inspection services background is where I see this also being applied is myself as an inspector can be aboard the aircraft as the inspector running the camera, zooming into what I want to look at, panning whatever I want, say if I'm inspecting a weld inside of a pipe or a tank or something. And up to here, let me do my thing. Okay, now go to the next one. Right, I don't have to fly it. I can do my thing. Right.
Yeah. And something I did not clear up with him was whether it was actually required to perform the rotations to have the second person, or if that was just for the demonstration of what the camera could do. I should have cleared that up, and I didn't. So there's that possibility. There's the possibility that he may not need a second person to perform that.
No.
As far as a requirement. Maybe for just precise control. And that's my shortcoming there. So
no, that's what I was really excited about was the maneuvering in really tight spaces. So kind of like the obstacle course we talked about a minute ago.
Yeah, he demonstrated.
Yeah, he lands it right on the wall, like he docks it horizontally on the wall, or vertically, right, and lands it there and sticks it to the wall.
Yeah, imagine one of those really, really small with a nice microphone.
Yeah. Yeah.
Or camera.
Exactly.
Suction
Just
cups
parked
and
against a
suction
window,
cups on it. Yeah.
even with like a contact mic, so you could, pick up the vibrations of people speaking from the other side of a piece of glass or something.
Way too many movies.
I like the way that Chris went about mentioning the product, the application of the Lynchpin itself at the beginning, and the way he manufactured it, the materials he used to manufacture it, and his way of going about explaining why he's doing and what he's done, why he's done that. I think because we're not. The Lynchpin isn't just resorted to just making drones. It's the concept of the shape and what it can do, the constructive, the weight, the cohesiveness of it. You can take it from that shape to a small shape. It could actually be a membrane of 1,000 pieces of Lynchpins that actually make a membrane for a wing. It has so many applications. The frequencies of it can be tried and tested in aircraft. I definitely don't have the flying experience that Brett does, but I've flown some aerobatic aircraft, and I still do, and I'm always interested in how those wings flex, how they twist, when we're doing the arresty system, the limitations of the machine, and I just wonder, with the way that we're making wings with the Boeing 737, 777, probably if we went from a singular parallel hexagonal shape to a Lynchpin shape of the same size, what difference would that make to the wing? So the application of how these guys are doing it and making it is, I believe, is a start. This is a start of what it can. The possibilities of this thing is just, it's crazy. It gives me a headache thinking about where you can have the applications of this thing.
Yeah,
Likewise.
Beautiful headache to have, though.
yeah.
Like to me, like this, it seemed very simple, like almost simple enough to overlook, where he was looking upwards and traveling upwards, and then spun around and looked downwards and traveled straight downwards. Like that's something that you would need either two separate cameras, or that's an operation that is incredibly practical, but incredibly difficult to perform. Like with a traditional, I come from the FPV world, and that sort of thing, you can't do that. Not in a controlled manner like that. With that level of precision. To do it indoors, it's not even like he did it on the outside of a 30-story building. He did it in a hallway.
Yeah, that was awesome. I thought that was great how he did that. That was pretty cool.
Yeah. Now keep in mind, each one of those four quadrants, in the apex of each one, you have the potential to put a separate camera in either one that will not interfere with the perspective of the point of view, by the frame itself, or you can put it on the actual vortices that you see, and be able to see, and maybe that systems operator and the sensor operator, would be changing the perspective depending on the direction you're going in. Or I believe you can actually program that directly into the Lynchpin, so that whatever direction it is going in, that's the main thing for the camera. But the operator has the potential to see in either one of those 576 degrees of aperture that the Lynchpin provides right there.
Another aspect of the camera would be that it doesn't have to be a camera. There's so many places that you can mount on a full-up Lynchpin, that you can put a camera somewhere, you can put an IR sensor somewhere, you can put a microphone somewhere. There's a lot of different things you can mount on a single vehicle.
I like the idea of coupling the IR sensors with a camera to create like live 3D mapping of an environment. I think is something that stirs my imagination. At least.
You know what? Before we show, Kevin, wait. Oh, we still have Mikhail's to show too.
Yeah, there's two left.
There's two left. That's absolutely. I'm so sorry for the time, you guys. I said we'd do it in an hour, but I was having so much fun. Okay, you go on ahead. Introduce Kevin. Now, what I love about Kevin is in the competition. You know, we showed them that you can do it with 6 reversibles, but in the directions, in an area called hindsight, and in the directions, we had a particle simulator that showed 12 opposing engines, vortices, and Kevin was the only person that actually went and did it with, you know, 6 opposing engines, and I'm just impressed with him taking on a challenge like that, even though it wasn't necessarily required. But he went the extra mile in the very last week of the competition. It wasn't in the first week; it was in the last week after a conversation, you know. And he said, "Okay," he took on that challenge. So, very anxious to see what you guys think about what he just accomplished. So please watch it on the Google Drive, you know, and then we can all comment on it. I think it's only a couple minutes.
Yeah, so Kevin he forked Betaflight, which is the most common FPV flight controller firmware. He forked Betaflight and created his own firmware, and he's been the sole developer, as far as I know, for probably a little over a year that I've been aware of it, at least. And you're right, like it wasn't until we had our call at the beginning of February with everybody that he that Terrence mentioned uh, the website with the 12 motors, and he scrapped his initial design and kicked it up a notch and did it with all 12. And it's a shame that this thing is being so herky jerky over the stream. But the one thing that I would like to at least note is how absolutely rock solid the movements of this craft are. It's just you don't see the stuttering or hesitation in the change of direction, or even in a dead hover. It is just rock solid, and it's a beautiful display of the concept, because up until his entry, you know, the 12 opposing motors were just a concept. You know, it was Chris's particle simulation, and you know, the theory that it would work, but Kevin proved it. I thought it did so beautifully.
Yeah, it makes good sense though, depending on how he planned the software and did the design. So all 12 of those motors could be complementary, and that would really smooth out some of those small perturbations, even for turbulence. I mean, you
Exactly.
could take out turbulence and not just aircraft motion itself in still air. So, you know, good job for whatever was going on in the software behind it.
And it should be noted that you can hear, if you watch the video in its original form, you can hear him say that I would roll it over, but it's way too windy. So everything that it's doing here it's doing in perceivably like high wind. He's out in Utah. He's the only American who completed all the steps that we asked for, you know, all the requirements. But it's still fairly impressive, I think. Not fairly impressive. It's incredibly impressive. Just the certainty that it moves with is, especially if, you know, I can't tell how bad the wind was on this day, but Utah in February, I can imagine.
Is this the first video or the second one?
This is his first one.
Throw the second one up for him. Oh. But the fact that now, can you speak on this a little bit, Brett? The relationship between the engines, that proximity, and having to be time and things of that nature, and the communication between the props.
Sure, if the aircraft can sense its own motion and has some, if you will, some self-awareness, It can use that depending on how the software is put together and how the designer has told the aircraft to talk to itself and to analyze itself and go into these feedback loops. We use feedback loops of varying sophistication in lots of the current fighters, and it really helps stabilize the aircraft motion. So that may be what you're seeing that would cause the concept of highly stable. Rock solid is another word that I heard just a few minutes ago. And if we were able to see maybe some high-speed vertical with a stop, remember that agility discussion we had a few minutes ago? If we could see things like that, some high-speed acceleration to a quick stop, having the 12 motors and having some real smart software would enhance that ability. So that's I think what we're seeing here in Kevin's demonstration.
And is it possible, Chris, for you to demonstrate, to show the simulation of the Lynchpin inside that we use in the competition, or maybe James could pull it up from the competition, the Lynchpin in the simulator, because I've never shown that to either Brett or to Vance.
I can drop. I think we can.
And
I'll put a video in the chat here. Yeah, I can drop it in the chat here just a moment.
But in this video, it was one of the things that assured us or gave us confidence that it would create stable flight, because what it ended up doing, Chris can explain it. Okay, I'll explain it. What it ended
for 1 second
was utilizing all of those forces where those four, because here you have 6 pentagonal forces or vectors, 3 coming to each individual space. And when those 3, even if they're contractive and pulling together, when the 3 of them come together, they create a magnetic field, a negative discharging field. Now, oftentimes you would think that would interfere from side to side, but that's what everything does inside the universe. And in order to have any expansion, that is the result of 3 contractive forces, 3 sets of fifths that come together. And that's what the geometry of the Lynchpin end up demonstrating. And you would think that the communication between all of these angles, they would create interference and wouldn't create a harmonic node, but the Lynchpin ends up becoming its own perfect harmonic node that resists all of the force, not just the gravity, the force of gravity in the ground, but literally all the forces around the craft, becomes negligent. It's almost creating its own Magnus effect around itself. And I think that is clearly demonstrated in what Kevin just did there. But if we can pull up
So, quick question for you on that. So, are you saying that it's not possible for that to happen with only 6 engines, and that you have to have 12 to get the full capability?
Yeah, you have to have the 12. Chris, did we lose you?
Oh, he just got back.
No, I'm just multitasking here, trying to click on a bunch of stuff to get it opened up for you. Yeah.
I mean, the 6. That's why you always have lag as it's rolling over, but you have to resist. You can't just. You have to have the 2 of the 6 opposing forces, vortices. The 6 opposing vortices are what is what generates that complete balance.
Can you guys see that?
Yeah, to respond to this and just to talk about this and to respond to what Brett was talking there about. So yeah, when you have the 2 propellers opposed, you create sort of they're trying to pull a vacuum between the 2 of them because they're both pointing outwards in the vectors. But because your moments are all equal in all vectors, you end up creating sort of like a pressure bubble around the craft, and it also has harmonic resonance to the surrounding atmosphere, right? Because your pressure's outwards versus it's some feedback to the atmosphere. So what the particle simulation showed us was you'll see the harmonic resonance set up here, and it will literally form the flower of life in a particle field once it starts simulating here. So in this particular case, we have 5 linchpins bonded, each with the 12 props simulated in a vortex force. You could actually put the force vectors in the particle simulation. So your colors are blue represents slow, cold, and then the hot is your fast, high velocity. So its velocity vector is the color.
Disgusting.
Yeah, I totally get that. The discussion is, I mean, it's not even the same when you have 12 motors versus 6. So I mean, there's no way you could even get close to full effect with fewer than 12.
No. Which is going to be a stickler for the development of it. You know, it creates its own problems associated with it, but
The frequencies. What's the rotation? What, frequency over rotation? By the minutes, will give you a frequency.
And granted, there's going to be an energy consumption issue with that, but the maneuverability gain is totally worth the need for extra battery power or whatever propulsion.
Right, exactly. Yeah.
And
So
it would be nice to show that other video of his first entry. Well, when he was just demonstrating, printing the frame and making it stronger.
I think he shows a fair bit of that in his final video here.
Oh, great. Go ahead.
I think. And I'll kill the sound if it's problematic, but I'm going to try it with the sound on and see if it works.
This one cracked me up. True flight test. Failure, failure, failure.
Yeah, it's legitimate, that's for sure. Yeah. Now, I like also how he stuck really close to the original Lynchpin design that we sent him as well. Like, it looks like a really light frame, and it's semi-rigid, so he had some flexibility in it, which I thought was interesting as well. So it shows that the Lynchpin itself it must inherently dampen some of its own vibration and frequency. Now he's got the 6 too, and he's doing the reversible props too, right?
Everybody but Kevin, with the exception of Kevin, used the bidirectional propellers and motors.
He was the only one to venture forth into where the potential of absolute failure and not enough time, to reach the entry date.
Yeah, he did step out on quite a ledge because it was just a few weeks between the time we had our call with him, where you showed him, we went through the website with him. And he just took it on, and he didn't say anything for the whole time either. He was just radio silence, just working away at it. But I really love Mikkel's his frame structure. I think he solved that. I really like the way the supports are and how the outer structure of the Lynchpin is absolutely precise.
What are you guys' thoughts on him?
I'm trying to get a better look at the construction of it. I had to answer an email right then when it came out.
We can go. We can pop back to it as soon as this is done rolling.
Yeah.
You can sort of see the silhouette there, but
yeah.
Yeah, I'd like to see some more demonstration of agility as well too. Right now, it's just a good flying machine, but haven't demonstrated all of its capabilities, I'm sure. But this is the time to do that.
Right. I see.
Yeah, I think it's going to be hard, Brett, to decide as far as who's got the best flight demonstration, because Chris did
the design of that one.
Yeah.
And
Chris did the docking, and he did all the proper rolls and everything, and he did a circular, and then he did the orbit around the other drone, showing that you can maintain a focal point. So from a cinematic point of view, I think Chris's kind of took that one, but on the other side, Kevin had the 12, and it showed that it's actually more stable. So I'm kind of torn between those two at the moment. That's where I'm at.
And he has these, which are easy to miss, but I believe these are sort of like mating points for other linchpins.
Yeah, and I thought landing
nice
feet too, right? It keeps it off the ground a little bit, so your props don't hit.
Well, right. Maybe both.
Yeah.
But it's a brilliant design. And this is I just want to rewind this part because this is, to me, was so impressive when he sent this clip over of the drop test. There's like one point where I won't go frame by frame, but there's one point where it's at its most, the impact is at its hardest, and the frame just flexes almost entirely outwards. And that's 3D printed. Imagine if it was made of, I mean, that's like a consumer grade 3D printer.
Yeah, consumer grade plastic.
Right. So it's I thought it was interesting. I thought it was.
And that one actually gave me a bit of a design inspiration too, Terrence. We didn't really talk about, but in the event, like where your joints are in the frame, if you made them semi-rigid and then had the rest of the frame rigid, you could actually kind of be prepared for those types of impact. Give it a bit of flexibility, right, to take on an impact, like a crush zone in a car, for example, right? But it would recover.
Design changes that would have to go to based on sizes. So some of the very, very small ones might be a little different than some of the very big ones.
Yeah.
Well, that's the thing too, right? The smaller you go, your Reynolds number changes, and then your characteristics are totally different, right? There is a limit there too that we were talking with Dr. Chris. There's some limits on that, and I think it's worthy to note that Dr. Chris's PhD thesis is actually on drone technology applied to atmospherics, and the Lynchpin solves that. One of the problems he's trying to solve in his thesis is solved by the Lynchpin, where they can fly in like a grid, and basically the voltage resistance for them to maintain a stable position can be translated into wind speed, right, coming at the drone, and then you can use that to map your atmospherics and create wind roses around wind turbines, which is what his thesis was on, how to map wind fields for wind turbines.
Yeah. I'm also with you. I'm pretty high on the good doctor, his agreeableness, likability. Because remember, the main part of the competition, we already knew that the Lynchpin would fly, and we could use any software that's out. But the main part of the competition was to find the people that were out there that would have a passion for this, that the geometry would speak to them. Because you got to remember, all of this comes from sacred geometry. So it has a voice and it has spirit to it. And people are going to resonate with it. And I was hoping that someone out there would resonate with it, or enough people to where we would be able to continue building our team. Because right now, as it stands, these individuals are the experts at building Lynchpins. I've never built a Lynchpin. I've never built a Lynchpin drone, to use it as a drone. I've built so many Lynchpins. So, but these guys are the experts at building them as a drone. So why not build the community from the people that's already shown a passion and shown an intuitiveness, and have been willing to take on the risks associated with this. The fact that only 4 people out of the entire world, and I believe how many people did we send the kit to, James?
I'm not sure. I'm not sure how many people have purchased the kit, but I can
No,
tell you that at least 25 people showed interest immediately. And out of those 25, these were the only 4 to get to the end.
yeah, and 1,500, if I'm correct. We sent 1,500
Oh, in the quad box.
in
I'm
the
not
quad
sure. I'm not
to,
sure.
out to the community. Well, that's what I was told. I know it was a large number, just to give people an opportunity to see and witness and feel the Lynchpin. And then from there, hope to inspire them to other works. And these are the only people out of all the people that are interested in FPV that entered the competition. So, I believe the Spirit actually called these 4, to this place, and you're guided and directed. One of the things that I've learned in working with the Lynchpin, one of the main lessons to my team has always been to always follow the geometry. When in doubt, follow the geometry. And the geometry never misleads you. And that geometry is what I believe has drawn everyone together now, because we're still here because of the potential. So I think because Kevin accomplished the biggest task, which was those 12 motors, in my book, he jumped the highest on this turn. But then again, Dr. Chris, his jump was the prettiest. And he allowed everybody to see what he saw. And he explained what he saw. So there's another thing that he solved that Kevin didn't solve. And at the same time, with what Mikkel did, that was magnificent. That was by building that frame, and improving on the frame. So they all worked on different aspects of it. Peter's was the fastest, but I would give it to Kevin right because of the 12.
So is our objective today to come up with a winner or maybe a rank order? Because in the last 5 minutes, I've rank ordered these guys.
Okay.
Let's hear it.
Are you sure?
I'm
Do
sure.
it.
I kind of done this. I kind of done the same.
All right, so I got to get on video to do this. So here we go. I go with, let's go in reverse order. I'm going to go with Peter as number 4. I'm going to go with Michelle as number 3. And runner-up is Christian. The winner is Kevin.
Wow. Same.
I got. I have Peter, Caleb, Kevin, and then Christian. I like the application and how the obstacle course type of thing that he showed and did and allowed us to see that there was just something special about the way that not only his understanding was very clear through the whole path, but the application of the process was there for me. He explained it to me, and I, like Terrence, have never flown a drone. I don't know anything about him, but I felt like I understood what he was trying to do there. Kevin with the 12, I thought that was a definite step over the hurdles that no one else went for, and definitely had weight there, and it was a great design. Michaela and Peter, they were very similar in their process to, I did like the 3D printing application of it. That was kind of cool. I would have liked to seen that one being printed. But yeah, I think I have Chris first.
Can I do a reattack?
Sure.
Or should I wait till the end, till everybody else?
It's up to you.
All right, here's the reattack. I think the technology leap to go from something that already has 12 engines into something that is a little more well-developed to fully operational is probably easier than everyone else who's only done 6. There still may be some significant design challenges, shall we say, to go from 6 to 12 that someone has already accomplished.
Yeah.
Mm-hmm.
Right.
And that's why I put him first, because like I said, it was nearly a toss-up between Christian and Kevin. But going to 12 knocked it over for me.
Yep.
From my perspective, I'm with you there. My would be the same rank order that Brett has as well, and I would put Kevin with the 12 at first, and then Christian right behind, and then the other two. Same thing.
Wow. Yeah.
Can we do a tie? Because I'm kind of the same. Like
Yeah.
I can't decide really. I can't really decide, to be honest, between the top two. They're so close.
Well,
Kevin and
yeah, it's between them. So this is my thoughts on it. James, you have the same. What's your order?
Okay. So for me, I think I just want to say this before I try to rank order them. I think that each of the four people had a strong, like one aspect they solved better than the other three. I think each of them. So it's very, very difficult for me to choose because each one excels in one area so much better than the others. But I think if you're going, if in my mind I'm looking towards a practical application, I would probably go with what appears to be the consensus order, which would be Peters, because it's a fantastic foundation, I think, and then Mikkel, because his structure, it has a lot of it has a lot of promise for many reasons, not just strength and creativity. And then I think Christian, and then I think Kevin, and I only pick Kevin over Christian for one reason, is that I think it's a much shorter leap to implement the camera system and the dual pilot control system onto Kevin's design than it is to add and program the 12 motors to work on Christian's design. I think it's a shorter leap from Kevin to Christian than it is from Christian to Kevin. So I think Kevin came out on top. You know, I think it's not easy for me to say that out loud because I've been hoping for the last month that I didn't have to say that out loud to anyone because it's not easy.
And it's the truth. That 12, that he did it. He did it. But all of them actually some greater portion. So is that 5 contestants with Peter?
It's
Or-
four with Peter.
So we have Kevin, we have Chris as number 2,
Mm-hmm.
and we have Mikkel as number 3.
Yeah.
Number 4, becomes Peter. Well, I'm going to give the first 3. I think all 3 of them, because of what they accomplished, I think they all should receive first prize and split that first prize. I think they all should receive $25 for what they accomplished. I think it means a lot for what they accomplished. Can you guys hear me? And then I believe the second prize would have to go to Peter, but I'm not certain because of some of the things that Peter did. If he should still be allowed to compete in the competition. One of the main reasons for the competition was that flight controller. And I believe Chris was on the call when we tried to, talk him into following the competition. And he was pretty strong about not following the competition side. If you remember, well, James, you were on that call as well.
Yeah, he's a very strong advocate for the open source projects.
Yeah.
A lot of the minutia of open source and GPL and all of that go way over my head. I know there are rules and that must be adhered to when using an open source project. But I can't say for sure that he had to based on those rules or not, or if that was just a step that he wanted to take.
We had a conversation with him, and everything short of pleading with him. not to release it before the competition was out.
Yeah, that's
Yeah.
how I
Terrence, you
read it.
and I have talked a little bit before about, not giving away, all the secrets.
Yeah.
So I would almost say that putting things out there for open source is borderline disqualifying. There's some things that are going to happen to this program later on, I forecast, that's going to require everything to be super close hold. And software is probably the most important part of that. So, no.
Yeah, that's what I feel. He disqualifies himself from the competition, even though he was the first one to get there. And, maybe the arrogance of putting the stuff out there, it really helped everybody else. But I think it hurt him in that regard. I would love to continue working with the other contestants. I really like their spirit.
And let me just pile on to what you just said. It not only hurt him, but if we continue to use something that was sitting out there open source, it would eventually hurt the team.
Yes, completely. And we couldn't trust him inside because at any given point he would release everything that we worked for. So I don't think he'd be qualified, based on those steps, and looking at the contract. But I think the other three should all receive $25,000 and share the first prize. What they brought. Now all they have to do is I want to send them here so we can keep flying. Know that they really work, but we've got 3 first place winners.
That's beautiful. That's beautiful. That's I can't even think of anything to say. That is gonna be. They're gonna be very happy. They're gonna be very, very happy.
Yep. So I'm happy.
That's amazing.
Thank you guys so much for taking the time to get on here and do this and to judge. I mean, these are really good guys, and they had no idea what would be the result. But look at what we punched through that wall that they set up and said what was possible. We've shown them that the impossible is the reality. I think we continue moving forward from there. And I'm sorry to all the people that didn't listen to Vance when he brought the Lynchpin to him years ago. AT&T treated me the same way, but they basically told me never to come in that door again with a
Yeah.
thought it could benefit them.
Well, it's like so many other things. You've got to catch the vision, and 4 people caught the vision, and 1 guy really caught the vision. So I think that's spectacular. This is one of the best judging things that I've ever had the opportunity to participate in. And looking forward, oh my gosh, I don't even want to think about where this is going to go. It is going to be just flat amazing.
Yeah, we're moving, and we're going to move at jet speed. What you guys are about with jet will absolutely blow your mind. Maybe you guys will feel like you're in the T-30, like I was in. That's that experience will only be topped by being Dr. Lynchpin. Vince, thank you so much. You're one of the busiest men I know, and I love you so much for coming and you helping us in doing this and for being a part of the way you've been a part.
It's my pleasure. Thanks for the invite to join and meet all you interesting people out there and same vision, and I hope I can stay a part of it. It's been a real pleasure for me. It's been a 3.5 to 4 year journey for me. So squeezing it in between flights and traveling and stuff like that, it's been a lot of fun. It's really cool though to see, and I think that's a very generous, loving thing that you just did, Terrence.
Well, I think that we have room and much need for a materials engineer to make this thing a reality. Since we talk about frequency, withstand vibration, modular, space exploration from our very first conversation.
Yeah.
I'd love for you to be a part of this. Future.
Absolutely. It's awesome.
Magnificent.
Yeah. Well, gentlemen, I actually have to sign off. I've got Singapore calling in about 2 minutes. So, but it's been a real pleasure, and I hope to talk to you all again. And I wish you all very well. And I'll talk to you soon. Thank you so much.
Thank you.
Pleasure.
Thanks.
Vincent.
Thank you.
Take care,
Take
Vincent.
care. Bye-bye.
Appreciate it.
Bye-bye. Yeah, I got to get inside too, you guys, but I thank y'all so much. This is what we want to do. And James, you got your hands cut out, your work cut out for you.
Way to go,
James.
James. Good job, man. I can't wait to see the finished product.
Thank
If
you.
you need me to read something, Terrence, you know, call me. I'll just read something for James.
Fair
But
enough.
everybody, let's stay connected. Let's stay connected. And like I said, some
Please.
stuff I wanted to share with you before, Brett, you know, about the potential and the other demonstrations that we've done with the Lynchpin, you know, with it in the as its ability to predict the distribution of matter or to predict, you know, certain events taking place. All of these things I would love to, you know, take an hour and let me and Chris walk you through some of the beautiful things that we've explored on this to broaden your understanding, because what you just gave us today was golden. It was the most eloquent, most respectful, and it just speaks volumes about you. And I'm so thankful that you did this.
Yeah, thanks a lot. And I think what you just suggested is a logical next step now that the contest is kind of over.
Mm-hmm. Yeah, it's time now that you learn some of the secrets of it, and that's the fun stuff, man. That's
Can't tell you, man, it's classified.
I feel like I'm sending my kindergartner, my child off to the first day of school ever. It's like this thing I've been like shepherding through the dark for the last like 4 months is finally like being passed on to the next set of hands, and it's exciting and frightening, and
Ooh,
I'm
they grow
happy
up so
and a little
fast.
and a little sad, you know. But it's very exciting, and this call was just wild. This is such a fantastic thing to be a part of. I'm so grateful just for this chair right now. So thank you.
I'm so grateful for these new 3 individuals that I'm going to ask to be a part of what we're doing, because they all 3 tackled a different need. You know, one with the frame, one with logistics, and one with the engines and the speed. And I think each one of them can really add to what we are building and building on, and they can build their own teams, because I know each and every one of them have their own teams that they work with, and we really can hit the ground running.
But imagine the design when you combine all of these 3 guys. Imagine the design that can come out of that if they work together.
They've never even met. I can't wait. I can't wait.
Well,
it's going to be crazy.
Is they're going to judge each other. You know,
Mm-hmm.
they're going to watch each other's thing, and they'll judge which one, you know, who they think should be declared the winner. You know, I think all 3 of them are winners. Tomorrow, they're going to sit on a call and judge each other's competition.
Cool.
Yeah. Or we should just send them a video of everyone and let them really say what it is. We don't even have to go too far, but we could video them. It would be really nice to have a conversation about it.
We
That's
could have
what.
a cage match.
Mhm.
There you go.
Just lock them in and say, you know, whoever comes out.
Give them an inflatable sumo those inflatable sumo outfits. And
Oh, how funny.
But we have all of them watch it at their own leisure. Everybody's stuff. Everybody get a chance to watch it, and then we pull them on a call. You know, that just another Skype call. You know,
let me see if we can successfully yank Terrence in here. He's ringing. He'll pop in a moment. It's always there. He is.
can y'all hear me?
Yes, sir.
How are you guys?
Very fine, thanks.
I can't even imagine how to express to y'all how really grateful I am for everybody entering the competition for the amazing work that you guys all accomplished. And everybody seems to have accomplished a different challenge. You know, the good doctor, Chris, with what you did and your organizational skills and handling the logistics. I know but I know some, but I'm in the middle of a call. Um, all of the stuff that you did, you're an organizational genius, and so qualified to really run a huge corporation. The framework that was created, was that Mikhail that did the framework?
Mhm.
I mean, you made,
Got it to fly too.
yeah, got it to fly. The plain and simple, every single one of you guys deserves a first prize. And so everybody's going to get $25,000 for what you guys have accomplished in building what you did. So if that's okay, if that works for any of you guys. But Kevin, when you did the 12, I think it's only fair for what was accomplished and all of the work you guys put in without even knowing what would be the end result, that everybody gets to walk and share that first prize, the prize money. But Kevin, like, you did the 12. You did the thing that nobody said could be done. And everybody did amazing shit, but that's a big dog walk. That was a big leap, and it could have failed, and you only had a week to get it done. It could have failed. So, big risk, it's gigantic rewards, and I hope this is the beginning of really a beautiful, working relationship and all of that stuff of where we're about to go. I'm really, really, really happy, and we'll have a lot of conversations I'd like to have with you guys. So, ultimately we have to send the linchpins here so I can see them and know that they're flying, and then send the code over that you guys use, and then you guys all will get your money, and you know, we can build a community in the best possible world. And just thank y'all. Y'all have no idea what it means to see the brightest minds in the world working on the newest technology in the world, and from your heart. You guys weren't hired. You guys just did it. You were called to something new, and I'm so honored and privileged to know you guys. And just thank you, and thank you, James, for
Of course,
making this possible.
of course. My pleasure. It's been great getting to know everybody, and it's been, and it all started, when we did that live stream is where most of them heard about it, and everyone said it couldn't be done, and everyone here on this call thought otherwise, and that's a lot, that means a lot, and
Yeah,
and it's one thing to do something that people said couldn't be done, but it's another thing to do it like in the face of very vocal adversity,
yeah,
like, and that's a personal, that's a personal risk to have to, to undergo as well. And that's, that deserves a lot of credit, it deserves a lot of credit, and, but, no one ever did anything new or pushed anything forward, listening to people like that,
yeah,
and to look past that, directly, at this dream that at the time, everyone seemed to think was incredibly far-fetched and unrealistic, but to look forward at towards that dream and say, you know what, I could do that, and you did. All three of you did that.
Just to get this straight, sorry to interrupt you, James. So you're saying you pay each of us 25,000 because you said sharing the prize money. It doesn't mean
yeah,
to split the.
yeah. No, no, no. Everybody will get 25 grand for what they turned in and what was accomplished. That's the reality. And if you guys were able to accomplish this on your own, can you imagine if we all work together? There's the future of the linchpin now. There will be the military applications of it. That's just, you can't get around that. I have meetings with the Department of Defense next week because of it. There's, but then there's the commercial aspect of it, the hobbyist aspect of it, which we have the spherical linchpins to accomplish that. Then there is the idea of turning it into starting since it's a new form of aviation, starting the Tangential Flight Corporation and making them large enough to replace the helicopters, moving them to put them into space, to mine the asteroid belt. That's what we're about to do. And I would love for all of us to talk about how to make that work and how to build that. So y'all go have a beautiful Sunday. I'm gonna sit here and try and be a good daddy today. But you guys really made me very, very, very happy and very privileged. So thank you guys.
Thank you. Before you hang up, Terrence, does anybody just want to say anything before we let Terrence go? Any last words?
I would thank you a lot also for the opportunity, because I would never ever have thought of building something, such a structure. It has been really amazing. A lot of stress, a lot of work and so on, but it was really a pleasure to work on it. And it has been a real pleasure to meet you. And so thank you for organizing everything.
Yeah,
it's been very, very beautiful.
I tell you that the gratitude from you guys came in the ingenuity and the imaginative expressions that you guys put into making the geometry of the linchpin, turning it into, the new. You have no idea the conversations that are going on right now, and they are huge, huge conversations. I asked my Washington guy yesterday, I was like, who's my competition? Who am I going to be displacing with the introduction of the linchpin? And it was like, I said, for the government contracts, and it was like, well, Raytheon, Lockheed Martin, Boeing, these are the people that get displaced by what the linchpin brings in. These are the people that are now obsolete. And they're going to have to license the linchpin and the technology of the linchpin if they want to stay, in aviation and aeronautics. That's how groundbreaking what we're involved in is. And you guys have just given me all of the ammo that anybody can need, all these different approaches to this similar thing. It's over. It literally is over. It's the biggest gamble in the world, and it just paid off, exponentially. So just thank y'all. If that's okay. If that's okay. Y'all gave me bragging points. I'm the baddest dog in the whole damn land now because of what you guys have demonstrated. So, yes, I know, son. I got you now. I gotta go, y'all. My boy, this is his day. But
take time for your family.
Yeah. We'll all talk very soon and this week and figure out logistics, if that's okay. Okay, I got you, son.
See you.
All right,
All
bye,
right.
you guys.
We'll let you go, Terry.
Yes, sir. Bye-bye.
Bye-bye.
So there's that. So, the thing that we tried to get across in the live stream, and we tried to make obvious without screaming from the hilltops, really, is that this sort of endeavor calls to a specific type of person. You know what I mean? And that really was the search. The search, wasn't necessarily. I mean, it's nice to have 4 flying linchpins, right? Because as we mentioned, people said it couldn't be done. People said it was stupid. So it was nice to hit that mark and say, no, you know what, it can fly, and here's what it can do, and then to award, some prize money to kind of just as kind of like a just like a flare in the night, just like, hey, we're here, we have an idea, and we'll see who sees that, but really the goal was to find some people that are open-minded and adventurous and fun to be around, because Terrence, as he said, like really he's got the ear of some amazing people, and he really wants to see this move forward in a really big way, so it really was a search for you guys specifically as humans, more so, or at the very least as much as it was to find the linchpin itself. So you all have a wonderful day.
It was good meeting all of you.
Have a nice day or nice evening.
Yeah.
Have a nice evening. Thank you very much.
Absolutely. And it was nice to meet you, Aaron. Good job.
Yeah, nice to meet you all too. Thank you.
Yeah, of course. Take care, guys.